Hello and welcome to this podcast, which is a joint production by the Naked Scientists and the UK Government's Science and Innovation Network. On his recent visit to Chicago, the British Minister for Universities and Science, David Willetts, addressed the Fellows Forum of the AAAS, that's the American Association for the Advancement of Science. His theme was this special relationship between Britain and America, and how a spirit of competition and collaboration in science and technology can help to lay the cornerstone for a new 21st century economy.
It is a great honour to be in the company of so many distinguished scientists here today. It's also very inspiring to be here in Chicago, where you do and still do great science. It was here in December 1942, under the athletic fields of the University of Chicago, that the world's first controlled self-sustaining nuclear reaction took place, overseen, of course, by the great Enrico Fermi. The Atomic Energy Commission later said it was a gamble conducting a possibly catastrophic experiment in one of the most densely populated areas of the nation. You can say that again. But Fermi's calculations were right, and he joined a long list of Nobel laureates affiliated with the University of Chicago. And indeed, when I visited the Argonne lab on Thursday, I was presented with a small piece of the graphite from that original nuclear reactor, which is a very special gift that I will treasure. As the British Minister for Universities and Science, I want to draw on my experience to compare science and innovation in the UK and the US. And of course, I recognize the sheer power and scale of America's research and innovation effort, exceeding any other countries, including my own. Nevertheless, we do have some distinctive British strengths, and I'm confident that alongside the US, Britain is the best place in the world to do science. And that's why it's so important that we cooperate. We have been cooperating. We can do even more, and I'm here to promote that cooperation. The UK-US scientific partnership is one of the world's strongest. Between 2008 and 2012, we published almost 90,000 co-authored UK-US publications, and they had more than twice the impact of the average paper in either of our countries. Prime Minister Cameron and President Obama have agreed that science and higher education are the foundation stones of a 21st century economy, and that we have a responsibility to further our global leadership roles in these essential fields. The UK-US Joint Statement on Science, Innovation and Higher Education, signed in May 2011 during President Obama's state visit to the UK and refreshed during our Prime Minister's visit to Washington, places science and innovation at the heart of the bilateral relationship. And we can work together as well, tackling key global problems, working with emerging powers such as China, India, and Brazil. And during my visit this week, we've been able to take our cooperation further, especially, for example, in the field of synthetic biology, where we have secured some specific agreements. It's not surprising that British scientists choose to do work in the US at some stage in their career. This is not, as it is sometimes portrayed, an alarming brain drain. Academic exchange is something we should celebrate and promote. We know, for instance, that mobile researchers, on average, produce papers with a higher impact. In a globalized world, it is as foolish to be parochial about research, to cling on to every clever, inspirational researcher as proof of one's excellence, as it is to be insular about students who wish to study abroad. And of course, this exchange of researchers goes both ways. Indeed, we have the highest bilateral flow of researchers between the UK and the US, with over 23,000 moves in either direction between 1996 and 2011. One of our most prominent and charismatic scientists, the Nobel laureate Sir Paul Nurse, is a case in point. He left Britain to head up the Rockefeller University in New York and then returned to become president of the Royal Society. And I'm confident that such exchange of people and ideas can be good, not just for the individuals involved, but for our countries. In fact, we have got another form of exchange at this conference this week. I've been delighted to be accompanied by Chris Smith, who is a Cambridge scientist and also presents The Naked Scientist for the BBC. You may be wondering, naked scientist? Naked scientist? Well, it does move it up the Google search engine list. Who says we aren't enterprising in the UK? However, as we Brits are sometimes teased for being excessively apologetic, I'd like to focus on three distinctive strengths of our science and research in the UK. Our first advantage, and this is exactly what you would of course expect a Brit to say, is history. And history matters. Indeed, the data revolution makes it even more important. I buy the argument associated with Jim Gray and Tony Hay in their book, The Fourth Paradigm, that the next generation of scientific discovery will be data-driven, as previously unrecognized patterns are discovered by analyzing massive data sets. I don't need to tell you about the data deluge. But if data analysis is in the future, then you need good quality data sets to start off with, including ones tracking back into the past. And in the UK, we have some of the world's best and most complete historic data sets in healthcare, demographics, agriculture, and the environment. And the value of these historic data sets is increasing with new ways to access and analyze them. Our meteorological records in central England provide a continuous temperature record since 1659. We can use weather reports in captains' logbooks from centuries ago to track climate change. Indeed, one of the reasons for our key role in the development of modern statistical techniques is that we had more statistics to analyze. R.A.F. Fisher, the evolutionary biologist and founder of modern statistical theory, began his career at Rothamsted, and some of the experiments of that great agricultural research centre have been running continuously since 1850, making them the longest in the history of science. I'm looking forward to getting the result, actually. The continuous plankton recorder has been running since 1931, making it one of the world's longest-running marine biological monitoring programs. Even in the new issue of Space Weather, the most energetic solar storm ever known was recorded by a magnetoscope at Kew in 1859. Without this long data record, we would not know how violent such events could be. Our National Health Service has a wealth of long-term clinical data linked to unique patient identifiers and well-established procedures, of course, to maintain confidentiality. And that's why our Prime Minister recently set the challenge of sequencing the genomes of 100,000 NHS patients, starting with cancer and rare diseases. Linking anonymized sequence and clinical data will allow us to investigate relationships between genetics and disease and target care to individuals better. And I do believe there are great potentials for further partnership for the US and the UK in genomic medicine and other parts of our life sciences strategy. So I believe that scientists across the world, but especially now in the US and the UK, can work together to make the best use of the massive amount of data we now have, and that means shared high standards for data curation, ensuring that the data behind the papers that you publish is machine readable and usable by other scientists across the world. This is a challenge we are very aware of in Britain after the excellent report by Geoffrey Bolton and the Royal Society on science as an open enterprise, and it's a challenge which the Royal Society continues to address. I have focused on it in the Research Data Transparency Board, which I chair in the UK. And again, it's an area which we in the UK, working with you in the US, can tackle together. Let me now turn to a second distinctive strength of British science. We can be very nimble and light on our feet. After all, when funding is limited, you need to be extra creative. When Ernest Rutherford's team were trying to split the atom and funding was once more about to run out, he's supposed to have called them together and said, "We've got no more money, now we must think." Perhaps some of you with budget pressures in the US and the UK know the feeling. Well, you beat us hands down on massively powerful computers, particle accelerators, and lasers. Yet what we lack in power, we can try to make up for in precision and ingenuity. I see this when I visit the facilities that we have, for example, at Harwell, near Oxford. The diamond light source is not the world's most powerful synchrotron, but it is the most precise. The Vulcan petawatt laser is physically much smaller, but competes head-to-head with a national ignition facility. Your neutron scattering facility at Oak Ridge has 5 times the raw accelerator power of our ISIS, but we are at least as productive because we have successfully concentrated on a wide range of instrumentation and support for users. This is true beyond Harwell. It's true of our computers, where we use smart software to reduce the number of calculations you need to reach any given result, which helps to make them energy efficient. And let me give you some examples from space. 30 years ago, we opted out of space launch technology. Indeed, we've never really had a full space launch capacity of our own. You helped us launch our first aerial satellite, and then 6 months later destroyed it in an atmospheric nuclear test. It's what we call the special relationship. And so we are always having to cadge a lift on someone else's launch vehicle. It's no accident that it was a Brit who wrote A Hitchhiker's Guide to the Galaxy. So you find yourself having to pay hundreds of millions of dollars to launch a big satellite. That gives us a real incentive to make smart, lightweight, small satellites. And we now produce 40% of the world's small satellites, with Surrey Satellites the market leader. Being light on our feet means using our modest resources with maximum efficiency. With just over 3% of the world's spending on research and development, we produce 6% of the world's publications and 16% of the world's most highly cited papers, second only to the US. Indeed, we produce 3.7 publications per $1 million spent compared to 1.4 here. So we are a very productive scientific power. Let me now turn to our third advantage, which is the combination of breadth and geographical concentration. We have excellent research teams in over 400 distinctive areas. No other economy of comparable size has anything like this range of world-class disciplines, including, of course, the social sciences and the humanities. This breadth matters because, as you know, none of the major challenges facing the world today, climate change, neurodegenerative disease, energy security, can be tackled by one discipline alone. So this breadth matters. And all these different areas of research are happening not across a continent, but on one small island. Indeed, the curve linking Oxford, Imperial, UCL, and Cambridge is only about 100 miles across. And we have other great clusters around Manchester, for example, which is even tighter, cluster around Birmingham, Warwick, and Nottingham. A very strong cluster in the south of Scotland, linking Edinburgh and Glasgow. And I'm delighted also on my delegation today, there's Professor Mary Bounds from the University of Edinburgh. And in these clusters, we really are breaking down barriers between academia, industry, and government. That makes us exceptionally well collected. So, history, creativity, geography, these are 3 important assets of British science. But there are, of course, important lessons that we in the UK can learn from you in the US. And one of the main lessons I take from the US may seem rather paradoxical. It's the evidence of the crucial role that public agencies and funding can play in technological and scientific advance. You have a lot of public support for risk takers and for innovation, what's been called America's hidden developmental state. It's easy to underestimate because it's divided between different agencies, such as the National Science Foundation and the National Institute for Health, and then, of course, there's support from individual states as well. The algorithm that turned Google into such a colossal success was funded by a National Science Foundation grant. Back in the 1950s, the Cold War and the space race meant the Department of Defense was pushing for ever faster integrated circuits and greater computing capacity, and that led to firms like Intel, and Silicon Valley was born. Later, federal funding for research into computer networking at Stanford was instrumental in the development of the networking technologies that became Cisco. DARPA has, of course, famously excelled at exploiting high-risk, high-payoff ideas. And this powerful creative role for government agencies can be seen beyond the IT and the defense industries. President Reagan's Orphan Drugs Act of 1983 marked a major step change for new pharmaceuticals. This role of public agencies is often hidden behind a rhetoric which attributes all these gains to sturdy individuals acting on their own. The role of the federal government in driving scientific and technological advance is, of course, what the great Alexander Hamilton, your first Treasury Secretary, called for in his Federalist Papers. It is very different from Thomas Jefferson's picture of sturdy, independent farmers. Indeed, that is why America has neatly been described as a Hamiltonian state hidden behind Jeffersonian rhetoric. There is a common thread here. It's the role of government and its agencies in bearing some of the risks of innovation. Sometimes in the UK we beat up on ourselves and say that we do not have the culture of risk-taking that you have here in the US. But this is not some inherent weakness of the British. The real problem, I have concluded, is that we're often expecting companies in Britain to step in earlier and take on more risk than in the US. That's why our Technology Strategy Board is so important. It takes some of the closer to market risks, which in the US are borne by agencies like DARPA or the National Institute for Health. And I'm pleased that we are now developing the kind of approach to supporting innovation that has been so successful in the US. We have brought in catalyst funds, which finance innovation all the way from the research lab to the market. Our 7 new Catapult centres are shared R&D facilities co-funded by government and business. So the US government has not been afraid to back technology, and neither are we. And let me conclude, therefore, by briefly listing what I have called the 8 great technologies that we have funded in the UK already to the tune of over $1 billion. First, high-performance computing to harness the big data revolution. Secondly, satellites, both as a new source of data and powerful transmitters. Thirdly, robotics and autonomous systems, be they autonomous vehicles, autonomous subsea submersibles, autonomous aeroplanes. They say that the plane of the future is going to be flown by a man and a dog. The man's job is to feed the dog, and the dog's job is to bite the man if he touches the controls. Then, after those examples from the dry world of IT, there is, I would have fourth on my list, the extraordinary advances of modern genetics. And isn't it extraordinary that just when we're having these surges in digital technologies, at the same time we discover that the secret of life comes in digital form? It's just last year we were celebrating the 60th anniversary of that great moment when Watson and Crick strode into a Cambridge pub at lunchtime and said that they had found the secret of life. That, of course, happens often in Cambridge pubs. But, of course, on this occasion, they were right. So synthetic biology is my fourth technology. Fifth is regenerative medicine, opening up new medical techniques for repairing and replacing damaged human tissue. Sixth, agricultural technologies. Seventh, the new advanced materials. And eighth, the challenge of energy storage. And it was so exciting for me to go to Argonne and see the way they're rising to this extraordinary challenge of raising by 5 times the performance of batteries within 5 years. So, today, I have outlined the distinctive assets that Britain has when it comes to science, assets that mean we complement our friends in America rather well. We're each other's closest partners in scientific research, as well, of course, as in security. Indeed, these two links at the heart of the special relationship both trace their origins back to those massive wartime scientific collaborations, like the Manhattan Project, which had some of its roots here in Chicago, of course. It is a combination, that special relationship, of competition and cooperation, especially in some of the more secret or research areas of science, where you need a trusted comparator who does things differently, but with whom you can compare notes. RAF Fylingdales in Yorkshire contributes to the US-led work in tracking space debris using UK-designed algorithms. AWE Aldermaston have extremely sophisticated programs for modeling nuclear reactions that complement modeling done in the US. Indeed, I was able to visit the US facility at the Lawrence Livermore Labs last year. I had to sign very high classification security undertakings before I was allowed in to see the rows of grey boxes that could have been calculating US pension entitlements, so far as I was concerned. But anyway, in the UK, we're naturally always keen to check on how we measure up to the US in the Nobel Prizes League, and we do very respectably. But an interesting aspect of the Nobel story is what our two nations share. Over the last 12 years, there have been 4 Nobel laureates that both US and UK claim as nationals, including Professor Michael Levitt, who I met at the Nobel ceremony in Stockholm last December. He studied physics at King's College in London, as did his fellow Nobel Prize winner, Peter Higgs. He generously says that some of the work for which he won the Nobel Prize in Chemistry was done at the Laboratory of Molecular Biology in Cambridge, and now he's doing great things in Stanford. This is just one example of the ties that bind our two great nations. Our relationship is indeed a combination of competition and collaboration that keeps both our countries at the forefront of the world for science. I look forward to today's new fellows forming new ties with our scientists in the UK and across the world. Many congratulations to your new fellows, and thank you again for the opportunity to address you today. Thank you.